Hello! In this video, we'll be talking about RISC-V microcontrollers. RISC-V is a relatively new architecture. It's an open standard architecture that sets it aside from most others, originally developed at Berkeley starting in 2010. It has no licensing fees, so anybody can build RISC-V microprocessors however they want without having to pay fees or patents. And because of this, they've become increasingly popular, especially for embedded system on chip, where the processor is going inside a larger chip. The architecture is fairly new, and there's only one microcontroller widely available for RISC-V right now. It's the SiFive Freedom E310 Generation 2 chip, released in 2019, and it's available on several fairly low-cost boards. The Freedom E310 microprocessor is a microcontroller with a variety of things inside. First is the E31 microprocessor. It has a 5-stage pipeline like we'll be talking about in Chapter 7 of this class. And it follows the RV32I MAC architecture. RV32I is the 32-bit RISC-V integer instructions, the standard instruction set. And then in addition to that, there's several supplements. The M is for multiply and divide, hardware multiplier and divider. A is for atomic memory operations, where you can do access that's not broken into pieces. And C is for compressed operations. They're instructions that are packed into 16 bits instead of 32 for code efficiency. This processor gets reasonably good performance, benchmarks of 2.73 core marks per megahertz. So a fancy processor could do quite a bit better than that, but this is not bad. The chip operates up to 320 megahertz, which is relatively fast as microcontrollers go, even though it was built in an antiquated 180 nanometer process. And the chip operates off of 1.8 volts for the core, and then 3.3 volts for I/O to the rest of the world. The Freedom 310 has a variety of onboard memory. It has a 16 kilobyte static RAM for data, for holding your most common variables. In fact, all your variables, that's all the RAM that's built in. It also has a 16 kilobyte instruction cache for holding the most recently used instructions. It has two kinds of ROMs, an 8 kilobyte mask ROM that's programmed at the factory, and another 8 kilobyte one-time programmable ROM for boot. And all these really do is when you reset the processor, they point the processor to the right location to begin fetching instructions. And most of the instructions then come from an external flash chip. The processor has a bunch of I/O peripherals. It has 19 pins available for general purpose I/O that can be driven high or low. It has several serial ports, 2 serial peripheral interfaces accessible to the user, plus a third one for communicating with the external flash, an I2C, and 2 UART serial ports. Has 3 blocks for generating pulse width modulated outputs, a timer, and a debug interface over JTAG. Here's the pinout of the processor. It comes in a 48-pin QFN quad flat pack. You'll notice that the pads for this chip are underneath, so soldering has to be done by putting solder on pads of a circuit board underneath and then carefully aligning this chip and heating. It's not something that's terribly easy to do by hand. Of the 48 pins, the purpose is listed over here. 12 of those pins are power and ground, for instance VDD, I/O VDD, analog VDD, and so on. 19 are available for general purpose I/O. So here's GPIO number 9, number 10, number 11. 4 of them are used for a JTAG programmer. That stands for Joint Test Access Group. It's a standard for programming embedded systems. 6 are used for fetching instructions over SPI from flash memory, 2 hook up to the clock crystal, and 6 are for other control. Then these processors are mounted on boards. Here are 3 commercially available FE310 boards. In each one we see the processor, FE310 processor. The SparkFun Red 5 Thing Plus board is $30. It fits in a breadboard. It's nice and small, about the size of a pack of gum. One drawback is the pins don't come soldered by default. So you need access to a soldering iron to solder pins on. But that's the one that we're using in this class. For $40, you can get the SparkFun Red 5 red board, which is similar. It's a little larger, and it has the pins already soldered on for us. Weird thing about this is it uses Arduino pin numbers instead of the pin numbers corresponding to the processor. So anytime you want to talk to a pin, you have to look up and see how the pin numbers written on this board map to the actual pin numbers of the processor. One more option is the Hi5 board from SiFive. It's a bit more money, and it comes with Wi-Fi and Bluetooth built in. So all 3 boards are functionally similar. They all operate off of a USB connection that supplies power and lets you program and debug the board. They all also have an external power connector, so you could use the device without a USB connection. They all have 19 I/O pins tapped out to pins on the board, and the software is compatible for all of them. In this course, we're going to use the Red 5 Thing Plus board for our labs because it's the lowest cost and because it easily plugs into a breadboard. As we study what's on the board, we'll need to refer to 2 data sheets. The first one is the FE310 Generation 2 datasheet that had the pinout, the electrical specifications, for instance, what voltages are used, and information that would be relevant to somebody designing a circuit board. The main one we'll refer to in this chapter is the FE310 manual that talks about the specs of the microprocessor core. It talks about the memory map and the peripherals, and it has all the information that a firmware engineer or programmer would need.